Hello friends, let us start with number system. Hello friends, let us start with number systems. Number system is basics of mathematics, and with the purpose of any exam it is very important and have large importance in many chapters of mathematics. So let us start with the definition of number, because number system starts with the number. So basically number number is a we can in simple words, number is count or some calculation in the for the word count means in our daily life what we count how many bananas we have in our fridge, we count how many type of shoes we have, how many different type of colors are there in rainbow. So these are actually count, and that's why the same by the means of some calculation it means the mathematical calculation, but algebraical calculation or any other calculation that includes the mathematics is the number. So a number system deals with the numbers. So let us start with the classification of numbers. Since there are different type of numbers defined in the mathematics, we deals with the definitions. What are the definitions of those numbers? So let us start with the number. Numbers are of basically two types. One is the real number, another one is the imaginary number. Imaginary numbers has less significance in quantitative mathematics, or the mathematics that is asked in the different examinations. So it has less significance, but real numbers has more importance. Imaginary numbers are studied in the class 11th, or in some boards in class 10th. This is basically what we have learned, like iota is imaginary number I, and a real number. Let's deal with the real number. Real numbers have two types, means either it contain a point or decimal, or it is full number without decimal. So the points are called the decimals, and without points it is called the integer. Let's say for the sake of example, decimals are like 5.6, 2.33, etc. These are actually decimal. Integers are like -5, -10, 20, 0, 1. These are integers. Decimals are of two types, whether based on the division that contains the repetition or some pattern, like finite decimal or infinite decimals, or you can say terminating decimal and non-terminating decimal. So let's write terminating decimals and non-terminating decimals. Terminating decimal, it means, as the word itself signifies, terminating means decimals after the means the numbers after the point is actually terminated after some limits, like 5.723, since it is limited to up to 3. Like another example is 2.32, another example is 5.6, these are actually the terminating decimals. Non-terminating means these are not terminated after the decimals, like 2.5555. Okay, another one is 2.327876 dot 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 dot. We cannot define up to which this go. Like another example is 3.313131 dot dot dot. These are non-terminating decimals. Another classification in the non-terminating as, so let's stop here. The one basic point here to cover is that terminating decimals can be represented in PYQ form. Like example, when we take 5.6, we can write 5.6 as 5.5 and remove this point and divide it by 10. So it can be 26 by 5. It is of PYQ form, where P and Q are not having any common factor. And means PYQ does not have any common factor. P and Q does not have any common factor. So 28 and 5 does not have any common factor other than 1. So it can be represented as PYQ form. So these are also the range of rational numbers, means these numbers terminating decimals are also called the rational numbers. Another one classification is in the non-terminating. In non-terminating, you have seen the pattern like 2.5555, 3.3131. Since here's pattern, after this 2, this is pattern. After this 1, this is pattern. But here is in the 2.3287 there is no pattern. So based on the pattern, or you can say the period of repetition, we divide these non-terminating numbers into the numbers that can be represented at PYQ form, that cannot be represented at PYQ in PYQ form. Since so let's define those numbers in the PYQ form. Means let's say example of 2.5. 2.5555. This can be after some lectures we will see how this can be represented in PYQ form, but for now this can be represented as PYQ form. Another one is 3.3131. This can also be represented in PYQ form, but the number 2.32876 dot dot dot, this cannot be represented. There is no fixed pattern of repetition. There is no fixed pattern. So if the number has decimals and non-terminating decimals and non-periodic decimals, so those numbers are called irrational numbers. Means non-terminating, non-periodic, periodic means after some decimal, and fractions. It contains some decimal. Fraction. These are the basically three steps to prove any number as an irrational number, and these are the rational number. Again, rational numbers are numbers which can be represented as PYQ form. So this is the division of non-terminating decimals. Now let us divide the integer division. Integer into the three class. One class here, one here, one here. Integers, first division is the negative integer. Another division is the positive integer. And the middle is 0 itself, is an integer. Negative integer contains -5, -6, -1, and minus infinity to all the numbers to -1. These are negative. And from 1 to 3 to infinity, these are positive numbers. And 0 itself is an integer. Why I put the 0 into here? Because 0 is neither negative neither positive. But two classes are defined for this misconception, is that this hold means when we deal 0 as a negative, then we say this is the set of non-positive numbers. Means in this set contains 0, -1, -2, dot dot minus infinity. This is called non-positive. When we include 0 into positive, this is called non-negative numbers. This set contains 0, 1, 2, dot 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 infinity plus infinity. This is called a negative infinity. This is called a positive infinity. This is the classification of integer. Another important point to this lecture is that in simple words, what are the natural numbers? Natural numbers. Natural numbers. Natural number, the word itself comes nature. In nature, we use for mathematics. We use mathematics for counting. So the numbers which are used for counting are the natural numbers. Numbers that are used for counting are natural numbers. Natural numbers. So, so let us take which can be the natural numbers. From the above classification, will the imaginary numbers can be used for natural numbers? No, because they cannot be used in our daily life. They are meant for mathematics or higher mathematics. Higher mathematics. In the real numbers can be used, but is it decimals can be used for counting? It is fruitful to say that there are 5.6 bananas. No, either there are 5 bananas or there are 6 bananas. There are not any 5.6 or 5.8 bananas. So only the integers are used, and the integer, whether it is fruitful to say that there are -5 bananas? No. There are 0 bananas? No. There are always the positive integers that are used for the counting. So the all the positive integers are the natural numbers. Means positive integers or numbers are equal to the natural numbers. So natural numbers example is 1, 2, 3 up to infinity. These are actually natural numbers. So in our next class we will study those topics like different type of numbers, based on their divisibility. This contains prime numbers, composite numbers, and other numbers, and we will study the LCM, HCF of two numbers, and divisibility of different numbers. So let us stop here. You can find the link for this lecture PDF in your video link. Thanks. Okay, bye.